Okay, we have a MacBook Air. It's this is going to be our last repair for today. Let's see, 6:44. Let's see if we can get it done as soon as possible. Okay, so we already have MacBook Air board open from our last repair. Uh, the description of this says it says it's dead. I'm not sure if you guys can see that. It says the board is dead. So when they say dead, when the description says dead, it means the device does not turn on. That's what is meant by dead. Now, as usual, as you guys know, before we do anything, before we connect our charger to the device, we first take out the back cover. The reason why we do so is because we want to confirm that it is safe to connect our charger to the device. We do not want to connect the charger to the device in a situation whereby the device is liquid damage or there is what I would define as an active short on the board. And the moment you connect your charger, you will be doing more damage to the device. So before I connect my charger, I always make sure I am aware of the state of the board before I introduce power chain. Okay, the back cover is out. Uh, this is what it looks like inside. So because of the JTAG connector, as we can, because of the small JTAG connector, we can confirm that this is a 2017-2015 logic board design. The next thing we want to do is we want to disconnect the battery. Battery is disconnected, and then we want to check for short, before we connect our charger. So the multimeter is set to continuity mode. Now let's check for short, black probe to ground, and then red probe. Let's see on our PP bus. So this is an 820-00165. The board we have is also 820-00165. Let's flip to the other side of the board. We want to start by checking the voltage on the fuse, which is F747140. Let's see if I have a short there, and we don't have a short. And then let's see if we have a short on our PP3V42. That we can confirm from our inductor here, which is L1795. And we do not have a short there either. So now, since we don't have a short on our PP bus, we don't have a short on our PP3V42. So at this point, it is safe for us to connect our charger. So now I want to connect our charger to see what is happening. So the charger is connected. Okay, we have, show you guys that. Okay, charger is connected. We have green light and then we have amber. However, we have no fan spin. Now, this is a 2015, 2017. From 2011 MacBook machines, Macs, once the charger is connected, the device will start by itself from 2011. So with the charger connected and the battery disconnected, this should start by itself if it was in a if it was in a working condition. The fact that it's not starting obviously confirms that this indeed does not start. So the next thing we want to do, we see that we have charger communication. The next thing we want to do is that we want to check the voltage is present. We will not worry about PPDC in voltage. Why? Because if PPDC in was not present, we will not have the charger communication. We will not worry about PP3V42 because that plays a critical role in enabling our charger communication. And then as we can see, the charger communication, it's there. So we are not going to worry about PP3V42 or worry about PPDC in, because PPDC in is the primary power, is the primary voltage that goes into your machine from your charger. Now the next thing we want to do is we want to see what we have on our PP bus, which is F7140. We have switched our multimeter back to voltage mode from continuity mode. Let's see, black probe to ground and then red probe on our fuse. Let's see what we have. We have 8.6. Now 8.6 tells us, let's check on the other side of the fuse, let's be sure. Okay, the other side of the fuse, you have 8.6 as well. So that tells us that our SMC is not in reset mode. And then another obvious way you can tell if your SMC is in reset mode is if you have a green light on the charger, even though the battery is disconnected. Now, and then another thing also, it's um, uh, uh, the 8.6 tells us that the SMC is also allowing the PB bus voltage to go to its full completion, which is 8.6 instead of 8.2, 8.3. Now, also in that state, 8.6, this device will be able to charge the battery when the device is fully functional. So I'm just going to confirm that again. Our PP bus is 8.6. That is good. Now, the next thing I want to check, I want to see if our source rail is present. That I can confirm from U8130. So let's see what we have on R8133. Let's check if we have our source rail present. Okay, that is present. Let's see if the device is making, let's see if we have any SO rail that we can confirm at S7520. It's an inductor. Let's see if we have anything on the SO rail. Yes, we do have something on the SO rail. That is 5 volts. So what this tells us is this device is partially making its way into SO. However, as we can see, there is no fan spin and the device is actually not starting. So the next thing we want to do is we want to disconnect. We already the charger is disconnected. We now want to disassemble the device completely, taking out the battery and then the logic board to find out why the device is not starting. So one or more of the circuitry, one or more of the circuit, it's most likely having issue, which is why the device is it's not starting. So the next thing we want to quickly do now is take out the board to find out which section of the board it's responsible for that. We hope this is going to be a quick one. Because another thing is I don't want to be late for Salah. Um, it's I already made my Maghrib. However, Isha, I'm yet to make my Isha. It's not Isha time yet. However, but I'm trying not to be here when Isha comes, when it's time for Isha. So I want to make my way to the masjid before Isha time. So the earlier I can finish here, the quicker I can get moving. Okay, the board is out. Put the shell aside. This is what it looks like on the other side of the board. Okay, as you guys can see, it's pretty dusty. What I'm going to do is I'm going to dust it out. Okay, now I'm going to do a visual inspection to see what stands out. This is a 2017 board, and two sections on the board, it's a concern. So one of them, I'm just going to show you. This chip here, it's slightly corroded on this side here. You guys can see that on this side. On this side of the chip, here it's slightly corroded, and also there is a missing component here, and also see there's also a broken part there. So what you want to do is let's confirm what those are real quick. First thing we want to do is we want to address. Let's quickly address that of U7600 because 7600. Let's quickly close that and open it up again. Switch to single. Okay. Now let's go to U7600. E7600, yeah, E7600. Okay, so let's see we're supposed to get E7600 is supposed to is responsible for a couple of things. Let's quickly go to our schematic, show you what E7600 is supposed to do. U7600. So this is U7600, and it is responsible for. So it's a 1.5 volt regulator IC. Now, what we want to do, let's see if we have. So let's check our inductor to see if we have 1.5 volt, which is what it's supposed to give as an output. And that is on the other side of the board, L7630. Let's connect our charger and see if we have 1.5 volts there. And that is also an SO rail, so the device is definitely making its way to SO. Let's see what we have. That's BP bus. Let's check SO rail that's present now. Let's check this inductor L7630. Let's check to see if we have anything there. Yeah, it is present 1.5. Okay, so we do not have a problem. Yes, it may be correct because yes, we did find a bit of a corrosion there, but that is not our primary concern. Our primary concern is going to be on the second section that I showed you guys, which is this U7870. So let's see what that is supposed to do. U7870, what is that? U7870. U7870. Now U7870, it's a 1.5 volt SO LDO regulator. So we're supposed to get 1.5 volt out from there. Okay. Okay. So that is also critical. Let us see. So this is U7870. The maximum current is going to be 0.02 amps. Okay, now let's get another board for comparison because as we can see, we have a missing pad as well as what seems to be a missing component. So the component that is missing is this one. So R6111, R6118 is what is missing, and that is important because let's see that is missing. Okay, and then the other side that comes from our SPI RAM chip. Yeah, yeah, it's pretty much connected. Okay, so that is missing, and then we have a broken pad as well. So let's see. So the pin 4 is supposed to make its way. Okay, let's see if that is still the case. Pin 4. Okay. Okay. Pretty much. I see what we need to do here. We need to work. This is the section we need to work on here. That's the resistor that is missing. We have a missing cap. That's not so important, but then we need to put that back. We need to also recreate to be sure that that line is not. We also need to be sure that that line it's not broken. It's not affected. So let's first of all let's try to review our missing pad so we can put back the resistor that is not there. I want to check the healthiness of this line here. Pin 4 of U7870. That should have 3 point. That is where 3.3 volt S5 will come into the chip. Let us see if that line is healthy. Important. Okay. Now we want to put back the missing resistor. And also put back the cap. Those spin on that line as well. I'll show you guys what cap I'm talking about now. Okay. Okay. Let's check, see if that is in place. Okay, that looks good. Okay, so before we clean the board, let's see if we now have a fan spin. Okay, that's it. We have a fan spin. That's a beautiful fan spin. Let's see if we have an Apple logo. So what I'm gonna do before we test for an Apple logo, I'm just gonna clean the board so that immediately after we test for an Apple logo, hopefully we have an Apple logo. Then I can finalize the repair. Okay, board is clean. Just gonna test to see if we have an Apple logo. Okay, we just need the screen connected and the DC jack. Let's connect our charger, see if we have an Apple logo. We have fan spin. And by the way, you see that there will be no light on the charger because we do not have our IO board cable. That's required for the light on the charger to come on. So right now we're not interested in that. Our interest is to see if we have if the device is pulsing, which is that we can get to know by getting something on the screen. Okay, that's it. That is an Apple logo, and this it's a beautiful, successful repair. So this is gonna go to the standard testing procedure. The device will get put together, and this will be finalized, and then it can go to happy client. I'm just going to finalize the ticket, and then I can leave. 1809 and 1809. It's ready. Uh, okay, that's it. I'll see you guys in the next one. Thank you.